The with that in mind, here's an outline of my presentation. What crops features are required for hybrid development, what type of market conditions are required, what type of quality controls are needed, and what level of breeding strategy coordination is required. And of course, again, I'm thinking as a industry breeder when you have multiple breeders working on the same crop in some overlapping regions. And then towards the end, I'll be going more into how you can hopefully make these breeding programs more efficient using some of the resources that the EIB models have presented. So first off, on the required crop features, certainly need a broad genetic base that is at least semi-adapted to your target environment with freedom to operate legally across that germplasm pool. Certainly want to make sure you have at least moderate levels of heterosis among at least two major groups within that germplasm pool. And there's obviously a number of the self-pollinators that can't meet that target. And you also need to have the ability to produce high quality hybrid seed or clones with relatively low cost. Then going on into the market conditions, you need to, and I mean, this is not to do with breeding, but if you're going to make the investments, you need to be checking on these things before you put all your time and efforts into it. And that would include making sure that regional farmers have enough purchasing power to support high quality seed production. Okay? And in that case, I would give another BPAT related example. We started reviewing a sorghum program, and I just asked something about the environmental conditions, input levels for the crop. And I was told that sorghum does not get fertilizer. Like, okay, that seems odd to me. It's a grass. It's really going to respond well to nitrogen. And if you're trying to show the value of hybrid over an open pollinated variety, it's going to be harder to do that in a low input environment. Later on, or more recent discussions, I was still asking about what to me is an odd case of not fertilizing this grass crop, and was told that there was some in some East African program, okay, they're going to subsidize or give the farmers some fertilizer, and they tried this, and what actually happened was the farmers took the fertilizer and put it on their corn crop. Okay. The reason they did that is because there's a better way. I mean, the resale or value of surplus corn crop is much greater than that of a sorghum crop. Okay, so just some market dynamics there, but I mean, at that point, the market's not changing. I think I would be seriously considering just staying with open pollinated varieties for a while, as opposed to the larger investment of hybrids that might not be readily accepted by farmers in that region. Certainly, you also need to check on the variety protection laws that are going to support the seed company investments to produce good quality seed. And you're going to need a network of agronomists to evaluate and communicate the values of hybrid products. And certainly you need to have a good seed distribution team for timely seed delivery. So again, not breeding aspects, but things you need to make sure that are in place before you make a large investment of your time in a breeding program. Next, I go a little bit into quality control, and you have really need the ability to produce and store high quality parental seed. Now, more recently, or that's basically done with molecular screening of inbred and hybrids, I would assume most times. And even when you have limited resources there, if you have 10 good markers, you can do a reasonable quality control screen. Most cases, obviously, with a clonal crop that's heterozygous, it's gonna be more markers, a little more complicated. I haven't worked directly with those crops yet, so I can't tell you exactly how that works, but the concept remains the same. Certainly, you need dependable short and long-term seed storage facilities, okay, to keep this program operating. And you need a well-trained team to manage hybrid seed production. And at this point, I expect surely some of you are saying I'm kind of repeating the obvious, but I would say particularly in the CG system, going to be a little more complicated because in most cases, as I understand it, you're going to be basic licensing, whatever. You're not going to be producing the hybrid seed. You're going to be giving other people the inbreds, and then you have, and you don't control those people. Okay, so now you have some more quality control issues. You're going to have a contract that has some quality control standards in it. And if they are not producing quality seed, they have a lot of contamination in the hybrid, which means it's going to fail in the farmer's field. Okay, at that point, the contract is void. You take their rights to the inbreds back, and you're going to have to get someone else to produce that seed. Okay, and again, you need to build this into the system. Next, move on to a few thoughts on breeding strategy coordination. And again, to really make these hybrids successful, you need to develop strong heterotic patterns, and that requires long-term efforts of a well-disciplined team. And more specifically, what I mean is that heterotic groups are clearly defined and agreed on by all members of inbred and hybrid management team. Okay. And I can assure you, as a longtime breeder, you put any two breeders in a room and pick a topic, and they can debate it and have totally different points of view for extended periods. And, that's healthy scientific debate in most cases. But if you're going to really develop strong hybrids, you need to kind of ever get on the same page on a few of these areas. You can aid that process with reduced conflict by having a nice line coding system that aids in communication, and just by looking at the code, something about the pedigree or the heterotic groups that the lines belong to. For sure, though, there are still going to be new germplasm introgressions, and as new lines come in, they need to go through a well-defined process with team decisions on the use. Again, you could have these two breeders, they each pick up a line, they put it on a couple testers, and maybe decide one puts it on the A side and the other one puts it on the B side. That's a problem. Okay, you need to avoid that. To have a standardized introgression process, and everybody agree and place the new line on one side or the other. There will be exceptions to this, or things where it doesn't work out. Specifically, actually, many of these programs start out with open pollinated varieties and develop a series of inbreds out of those open pollinated varieties. And then you have some, and the lines go on different sides of the heterotic pattern. And now you have basically some contamination in what germplasm goes where, and breeders reluctant to give away their pet inbred from their breeding program. Okay, so you use it as a donor parent. They can extract the traits they like, but slowly reduce the amount of overlapping germplasm in the two different pools. Going on a little further then on how to make the breeding programs more efficient, suggest that many times sometimes this is not done, but the heterotic pools need to be divided as male or female, because this then can reduce cost and improve rates of genetic gain at the same time. And I'm saying basically this happens because the savings comes from reducing the number of traits that any individual line is screened for. Okay, and when you do that, you have greater genetic gain in the remaining traits. And for sure, in any of these hybrids programs, competitive seed production processes are critical. So you need to have a good focus on the ability of a line to be a male or female parent. Another part to consider is the fastest and cheapest way to advance new products is to stick close to a proven pedigree. A lot of breeders just work all F2s and looking for the big jumper, but you can see good gains, especially when you have some good genetic variance in your breeding pool when you work BC1 breeding populations. And as part of that process, you can use parents of the best hybrid product as stage 1 testers. And as you go on in the program, later stage tester numbers can be reduced based on historical knowledge of FCA. Okay, so this is kind of more of a KISS principle type of idea. And it also applies to the market, because when you want all this work, you want the farmers to pick it up and and the hybrid to get large market share as fast as possible. And market acceptance will be much faster for products that are introduced as being similar to an established product that the farmer's already comfortable with. And this new product just has improvements in traits X, Y, and Z. That's a much easier sale. Okay, so continuing on though, if you follow from that previous slide, you're starting to worry about genetic gain because I'm working back cross populations. Okay, well, there's still ways to deal with that because we certainly need to keep some good levels of genetic diversity. That can be done in two major paths. You can have targeted recycling within the diversity managed pools, and you can have periodic introgressions of donor parents as an ongoing population improvement process. And most likely you're going to have both of those, but you need to monitor the genetic diversity. You can also carefully select testers, and certainly early stage testers should have good GCA. And once you get into a larger program, you should have several hybrid replacement targets and different testers, and that always is also going to help you maintain genetic diversity. And then there's, of course, our favorite topic. I don't recall many breeders that enjoyed working on budgets, but it is critical, particularly for smaller or younger programs. And I would think particularly so in this semi-public sector CG programs where you're really looking for donors and partners continuously. Well, okay, one of the ways you can build confidence with other people is having a clean, presentable format for your budget and a plan. And actually, there's some new software. I hope some of you saw the webinar out of the Queensland University team where they have this nice costing tool. And if you take the time, and I started to play with it myself, it does take a lot of time to get all your information in there. And not having an active breeding program for this presentation, I just kind of punted in using some Excel spreadsheet kind of model, but still, it's a really interesting tool that I would strongly recommend you consider so to get an better understanding of all your costs. And as you're thinking of changes in breeding scheme, you can see their impact. And some of those key changes might be tester numbers and stages where tester numbers are increased, and that's a big cost factor. So it's not just a convenience choice. There's also things like off-season nurseries, which a lot of people are hesitant to use because they're usually away from the home site, fairly costly and so on to maintain. But the benefits, if this isn't part of your single seed descent or dihaploid production, rapid inbred development, can be very high. And so as you're going through this process, we need to remember to calculate the cost of genetic gains per unit time. So at that point now, I'm going to go into a little bit more of the impacts of product profiles. And so now we're going into things I hope you've already seen from previous EIB presentations, but I'm just making up two fictional programs or reflecting again the kind of things I've seen in BPAT reviews. But I mean, this would be maybe a maize program in Eastern Africa, okay? And we have traits prioritized and hopefully some culling levels or whatever in one program. And then another program, sometimes we come in there and well, they have a list of traits, but they're not really articulating very well when they're selecting for what, which one's really important to them. They don't have hybrid targets that they need to meet and so on. And so, some would argue that's some minor organizational issues. I'd like to outline a little bit about why it's actually a pretty important thing to get straight as you get started. And this slide is reflecting a little bit more of how I would suggest that might be done. Okay, so you have a trait, you have a priority of that trait, you have some information about the relative level of heritability, you have data point costs, because again, budgets are always critical. And then think about the timing of that information on trait selection, okay, and other considerate things you might consider. So for example, again, yield, always number one, unfortunately not relatively low heritability, and the data costs are pretty high. Okay, so what that translates to is that you're only going to put something in a yield trial after heavy filtering for weaknesses in highly heritable, high priority traits that you can look at in the inbred development process. Okay, now that selection will be limited a little bit, of course, because you have to watch out for any negative correlations with yield. Okay, dropping down this trait list a little further, we have northern cornleaf blight, common foliar pathogen, high priority in many markets. The good news is it's highly heritable, and just walking the fields and scoring it is relatively cheap. Okay, so what that means is you're going to have the high level of screening early before stuff ever gets into yield trials. You should not be advancing it. You got a 1 to 9 scale, and 9 is the best, then anything with a 5 or less is a discard. Again, before you get to yield trials, if you're generating dihaploids with fingerprinting, then QTLs could really be helpful in this process. Contrast that then maybe with Striga. Don't know that trait very well, but I know it's a difficult one and can be very important in a number of markets. Don't know how to really, I put the heritability as intermediate, but I mean, that's really dependent on how well you can generate a good screening plot, which is the major problem. And of course, no farmer wants to have a Striga plot near them. Okay. And so overall, because of the maintenance of that plot and so on, and then also the part where you have different races, as I understand, the cost of a Striga data point is quite high. Okay, so that means we're probably not going to be screening for it until, say, the second year of yield trials, and it certainly would be a high priority to identify QTL if you could to address this screening cost. So again, different trait, different situation. I'll do one more and say stay green. And okay, it's a low priority. It looks nice, and maybe it's interest relative to cattle feed or a little bit at some point, but not a high priority. The good news is it's a highly heritable trait and it's really cheap to score. But what's going to happen here is you're really not going to do anything about that trait till later stages. If you maybe have 20 slots for hybrids to move forward and trying to decide a couple between the two, you might go ahead and pick the one that has the better stay green level. So a nice to have. So again, just trying to give you an idea of the process of how these traits and understanding their importance and cost and so on would come into the process. So now, and I'm going back and I have these two fictional programs with different product profiles. And we're starting up here at breeding crosses. Okay? And in this program that has the better product profile that I'm recommending, we're going to select for all traits where parental data and GEBVs are available. Okay, don't know quite what's going on here. Maybe they're using a few of these traits depending on the data they have available, but it's not defined and it's scaring me a little bit, I guess. We get to stage 0. Now you have your new set of dihaploids or other inbreds. You're looking at them in the field, and now I'm selecting for all traits except yield and Striga. As long as there's a reasonable correlation between inbreds and hybrid, we can do a lot of cleanup there. Okay, this other program, I'm not sure they're just doing minor culling or what. But now it really starts to impact the budget, because if they're not doing effective culling at this point, then we're getting to these yield trials, which are starting to get more costly, and I'm carrying more entries that are just going to be dropped later. Okay. Now, as we go into stage 1, we are selecting for all traits except Striga in Artify, and we have clear criteria. Okay, so we're really cleaning up on the other traits and starting to impact yield. And again, we kind of got a fuzzy, not sure exactly what's happening here. And again, we have probably more lines being carried in the program than we do in the well-defined selection profile. And that's going to become more costly as we want to start our rapid recycling, start making breeding crosses at this point. Okay. And that's what related to the rapid genetic gain, which I hope, again, you're already familiar with. So now we go to stage 2, and we're more focused on yield and Striga because we've already cleaned up most of the other traits. Again, not sure what's happening here, but at this point, we're really wanting to cull down these breeding crosses because we might be putting them into dihaploid production, that kind of thing. Okay, and we only have so many slots available. So bottom line in this case is that you're going to have higher rates of genetic gains for all traits with reduced cost versus this other model. Again, just based on not having as good a product profile, you're going to have higher rates of product failure in later stages. And I'd say this can be particularly painful if you go back to the parental traits. It's common in the industry, certainly happened to me a number of times. You have a really high yielding line that you're interested in, and then it's stage 3 or so, the production guys get a hold of it and do an evaluation and basically say, no, it's not a good female, the hybrid's dead, you just wasted all your time. Okay, that's a really disappointing process that's happened to all the breeders in the private sector, and we certainly try to avoid it. So again, reviewing the impacts of these product profiles on the breeding schemes. Product profiles really need to be well defined with culling levels, targets for each trait. Trait cost will always be a dominant factor in the pipeline structure. And this becomes more important as you go into the rapid recycling because you need to take into account these trait costs and think of some other models. I mean, the base model I think you more commonly see for rapid recycling is recombining them after stage 1. But you can do things like take lines from stage 3, maybe 5 of your best lines that coming out of stage 3, and use those as parents one side and cross onto 50 or so of the best lines coming out of stage 1. So you are towards the relatively rapid recycling, but increasing the probability that those populations crosses that you've made, a good percentage of them will look good after you get 1 more year's data and you have the F2 ready to go into inbred development. Okay. So again, what I'm trying to say is we really need to use the full trait profile and selection of breeding populations to maximize genetic gain and to ensure good on-farm gains. And because all the traits are important, and the farmers will tell you if you release something there, you missed some of the traits that they require. So with that, I'm going to move on to tester number decisions. And this is a model that's already, or this work is already posted on the Module 2 website, okay? But it is done with some nice simulations, and that's very useful. But again, I'm the old breeder. I'm going to look at it more on just budget or basic resource allocation thing. And again, within private sector, you get, and many other places, you're going to get, say you had an allocation of roughly 20,000 yield trial plots. What are you going to do with them? Okay. Well, okay, here's one model with different, standard number of locations doubling at each stage, but just differing in tester numbers. Okay, and you have to work this math, and at stage 3, saying this is when you're going to code the inbreds, and that's typically a bottleneck, and you have a fixed number there that you can afford because other developments get more expensive at that time. Okay, so this is how the numbers play out, and the selection intensity, just again as an example. So it's pretty costly if you add these extra testers in terms of the number of entries you can evaluate, but you have to think about, what other selection have you done? I mean, this smaller number is not so bad if you've already cleaned up the inbreds for a wide range of other traits and you're just selecting for yield. Okay, so again, some things to think about. And another factor that's going to become more important as you make this decision is going to be the genetic similarity of the parents. And this is just a fictional program with 5 males, 5 females, but it is the kind of numbers in terms of genetic similarity that I've seen in some northern temperate zone programs. And I'm talking about a mature program, and they had their pet inbreds and they recycled them, okay, within a narrow pool. And so they've really significantly reduced their genetic diversity, available genetic variants, whatever, within. And so, genetic gain is getting harder here within this pool, both in the males and the females. Okay. On the upside, though, they have a strong heterotic pattern, and they're very complementary, and so they're probably doing a good job of maximizing heterosis. This is what some of those graphs look like if you were able to see them in some private sector programs. Okay, so that's one case. Now we go back to this model. Which one of these do you like? And I'm saying at that point, to me, it's a pretty clear choice, because these testers are not that much different. So spending all the resources to jump up the tester number is not going to do me much good. I'd rather have this larger number of entries so that I can find those recombinants for that extra yield boost within that relatively narrow genetic pool. Okay. So again, that's just one model. Now, let's say we move from the northern temperature zone and all their genetic vulnerability issues down to the tropics, where they typically younger programs, more diversity in the maize programs. I've seen a number of these similar type of tables in the tropical markets, okay, or tropical breeding programs as I traveled around. And so we have much more genetic variance. We're happy about that, but we're really not defining a good heterotic pattern. We probably are not maximizing heterosis, and we maybe have some overlaps in these groups. So we really don't have an efficient breeding program yet. A little messy here. We need to clean this up. Okay, but there are a number of programs that do work reasonably well. But let's go back again to this model of different numbers of testers. And now this tester number, again, if we've cleaned up a good bit of the lines going into here, we're just looking for the best hybrid combination, and we have a lot of genetic difference, distance between testers, then we can make some big gains in finding the best SCA pattern by adding testers. And so this model gets to look a lot better. Okay, so again, just different things to consider as you're working through your designing your breeding program. So at the end here, somebody said, well, okay, just tell me how much diversity is best. And my response is, no, I'm not going to I don't have an easy answer. First, you're going to have to tell me, do you have a sound data-driven product profile? I would like to see it, understand it. Then you got to tell me how important it is to produce a wide range of genetically different products in your market. What is your competitive position in the market? If you're just developing the first hybrid, for example, for a crop, you really want it to jump out and be much better than the open pollinated variety, and you want to be able to follow it up with an improved hybrid pretty quickly. So that makes that more narrow genetic model with limited level of diversity and very SCA targeted kind of program much more maybe appropriate at that time. Okay, there's also going to be questions about how fast you're able to address trait weaknesses. You can say you have this relatively narrow genetic pool. That's not that much of a hybrid. Challenge. Let's say you're in the temperate zone with one of those relatively narrow pools, but you also have a lot of molecular marker tools, and you have continuous nursery. So if it turns out a line has a particular trait weakness, you can put it in continuous nurseries and get the new enhanced version of that inbred within a couple of years. Okay, so that changes the equation as well. So in conclusion, I would say your product goals and diversity level of the elite parents must be well defined before a sound breeding scheme can be developed. Product profiles must include consideration of marketplace competition and risk tolerance for product failure. investment in continuous nurseries and molecular breeding pools can radically change the risk of these different breeding schemes. And in all cases, you need to clearly define the budget components so you can make sound breeding scheme decisions. So thank you for your time. I hope I raised enough questions for you to have a good discussion, and looking forward to that discussion.
Thanks, Randy. I think that was a great presentation. Yeah, there was several comments on the chat. I'll try to read a couple of them. First of all, I think, yeah, many people just think on the maize model, you know, when they talk about the hybrid breeding, like the best solution, because we always think on heterosis, but you're just showing that that's actually just one piece, and there's much more involved that every program that wants to get into hybrid breeding needs to think about. I guess there's a couple of comments in the chat about something very specific, you know, in your comment on the back process and sticking to a good pedigree for delivering products, and some confusion on whether that is the best strategy for genetic gains. And some of the people is you know, commenting that really the genetic gains come from the recurrent selection approach and targeting the genetic gains, and the BC or the back crosses just as a complementary approach for delivering products. But it's interesting to see that some people in the chat is mentioning that model probably will not work in the sense that I guess they want to have products instead of genetic gains. But I think it's valid, you know, comments and concerns. I don't know what's your take on that, Randy. I was just thinking that, you know, the numbers are concerning. The statistics really say that we need to increase the genetic gains. There's really no way back on that if we want to achieve the levels of production that we need for 2050. So I guess we cannot just stick to thinking that we just need products. I think that's why you know, we have these initiatives on increasing genetic gains, because we need to really start going back to the foundations and have good genetic gains as the basis for good products. But I don't know, what's your take on that, Randy, if you want to mention something?
It's kind of like I was saying, the timing of where the program is at this time. Okay, so again, if you have a new program and somebody gives you a grant or whatever, I mean, you have funding for, you know, a lot of those are pretty short, 3, maybe 5 years or whatever. You need to produce something and, you know, show that you have a pipeline. So that's much different. Now, once you start to have, you know, a little bit, I mean, if you're pretty certain you've got 10 years of funding, okay, then that changes the equation. I mean, yeah, there's no question that you need to have this larger breeding pool population that you're enhancing. And maybe it's a combination of both, or it's a timing of where your breeding program is at would sort of be my question. I mean, there's no question that the rapid recycling and population improvement is a key part of where we want to go. But again, I mean, some of these programs that I've reviewed, they don't even have a planter yet. They have other quality, I mean, basic issues that they have to generate products to fund.
Mm-hmm.
So I guess I would just call it trade-offs.
Yeah, I agree. And like I said, I think all points of view are important. Thanks, Randy. I think there is a comment or question from Jan. Jan, do you want to jump in?
Yeah, I think we have to differentiate between what our objective is in our breeding programs, especially for the CG, which is population improvement, you know, rapid generation cycling, etc. And now basically portfolio management, which is really, you know, what does the market needs, and if we can do that with adding trait to rapid cycle backcrossing program to enhance the portfolio. But that is not really, I would say, as Gary pointed out, that's not necessarily the main emphasis of most of the CG breeding programs, I would say. So really differentiating between, you know, the breeding, you know, population improvement versus managing a product portfolio, which is kind of late stage and you know where product managers would come in, and so really kind of separating these types of activities between you know, again, population improvement, rapid generation cycling, having a breeding pipeline with very well-defined traits, versus, you know, how do you manage a portfolio for seed production and making sure you get a return on your investment.
Yeah. No, thanks, John. I think that's a good comment.
I'm wondering if it might be divided among different groups. I mean, let's say the CG, you know, they develop some good base inbreds, okay, and maybe the one of the NARS picks it up, and then they have a more specific market, and that might be where the backcrossing comes in, as opposed to the ongoing population improvement within the larger CG program. That makes sense?
I think that would make sense. I don't know. Any of the breeders want to jump in? I can see that Gary, you want to say something. I also encourage you know, the breeders in the CG working with hybrids to say something. Gary, please go ahead.
Yeah, I mean, on the whole, we're not dealing with programs that are starting up and need to rush into the market in 3 years or 4 years to survive. That's not our main clientele here. Going forward, the type of breeding that's going to be funded is really collaborative networks that link together small, you know, relatively small national programs in sub-Saharan Africa. You know, for the main focus of funders like the Gates Foundation. And these are, you know, these are ongoing programs that have been around for a long time. And these networks are able to help small national programs link together and leverage each other's testing capacity. You know, many programs really aren't able to test at enough locations or run enough plots to generate a reasonable level of accuracy in testing, but they can if they're linked together in a testing network. And so that's why we're really focused on driving populations quickly to maximize the rate of genetic gain in the source populations. Because if you do that, the inbreds you extract from those source populations are going to be pretty good. And if you know, if your cycle time is 2 years, and you miss a product replacement in 1 2-year cycle, you'll likely get it in the next one. And this is going to require shifting resources. At the moment, we invest a lot of resources on the public side in the maize programs on hybrid selection at later stages, and that's probably a misallocation of resources. If the populations are improving, we don't have to spend as much time trying to find, you know, the absolute best combination. Pretty good will be good enough for any given cycle as long as we keep the cycles improving. So that's the difference between the sort of population improvement GCA oriented mindset versus a situation where you're struggling for market share. And you need to really have a product that's much better than your competitors. That is the case in the U.S. Corn Belt, for example. It's not generally speaking the case in sub-Saharan African markets or even in South Asian markets. So that gives us the opportunity to focus more on driving population improvement, driving genetic gains in these populations.
Yeah. Thanks, Gary. And I think we, well, most people agree that that is a good strategy, as you mentioned, to extract good products in the medium, short, and long term. Felix, do you want to elaborate on your comment? You were mentioning about the issue of really being able to use some of the elite inbreds in the public programs. You mean when the program doesn't have like a very good population and you need to look for elite material to start the program or to just enhance it? Or can you elaborate a little bit, Felix?
Yeah, I mean, my comment was also going in the same direction as Gary's, and in terms, you know, a lot of the programs, public programs, are small, and the capacity even to run a population improvement program sometimes is limited. So, I mean, I understand. Of course, they're not running for a market share, but they need to have some capacity to use some of these lines coming out of the collaborative program, particularly from Global Maize program. You know, we're producing a lot of inbred lines, and we can see that sometimes there are limitations in the public programs to use these lines efficiently in their own programs. So that's what, at the end, most of the time, they're just taking up the final product that CIMMYT is launching, and they're trying to have some impact with those. So my concern is that, I mean, the proper, you know, connectivity among all these public programs to make the proper use of this population improvement approach.
Yeah.
I don't know if Gary can comment or I mean, Randy. I mean, it's just a point for discussion, I think.
Yeah. Any take, Randy?
I think that the you know, that's the argument for linking together in a well-coordinated network where, you know, the national partners work together with the CG program to design the product profile, make advancement decisions, choose parents, and put together the testing.
Okay, but those smaller programs, I mean, they're going to want to have their own products to an extent, so they're going to be making different combinations. You know, and some are going to do 3 ways. Other issues that we still have with maize outside of the U.S. is this use of 3 ways. Okay, and so that's production cost, and maybe a limited focus on trying to develop good females. I don't know. But the point is that you need to have some heterosis there. There's a lot of different combinations there. And there is a distinction when I'm saying that you have to have everybody on the same page in terms of the breeding pools, the heterotic pools. That's in terms of the breeding and recycling. That's not in terms of the final hybrid product. Okay, so because we dealt with that a lot in the past of people making hybrids in different directions. The basic rule as we transitioned was always, you can make a hybrid anyway, any 2 combinations of lines, 3 for a 3-way, whatever, that you can make a competitive product, you should do it, okay? But now when you make breeding crosses, we all need to be in agreement that if it has this, in maize, tuck spaniel-based germplasm, I don't know what whatever, call it A, and if it's like more of the Eto and so on, it goes on the B, okay? So again, those are separate issues, kind of like population improvement versus final hybrid product development. That makes sense?
Yep. I think it's a good comment, Randy. I don't know if Felix is okay with it, or if people wants to comment on that. I would like to actually take advantage of you know, some of the breeders here are working in the clonally propagated crops, and some of them want to you know, explore hybrid breeding. I don't know, Randy, have you spent some time thinking on the potential differences that they may have? I mean, many of the things that you mentioned, I think that they are very general in the sense that they really apply to everyone. Of course, they might not have the same issue on, you know, producing the seed. I mean, once they make the hybrid, they can just propagate it more easily, I guess, than, for example, trying to make hybrid wheat or something like that. But But I don't know, do you have any take on the clonally propagated crops, something that you can more or less foresee that would be different or that is would be a concern or something in addition to consider? And I don't know if any of the readers also want to jump in. Please, I encourage you to take advantage that Randy's here with us.
Okay, the question is about clonal crops?
Yeah. Do you see any difference? Have you thought about it? It seems to me that what you're explaining is pretty much applies to everyone. I don't see really much of a difference other than the producing the seed might be different, and I would say might be easier for the clonally propagated crops. But do you have any?
Yeah, the purity thing would be, I don't know how. I mean, you'd have to run a good number of more markers. I mean, to define that you have. I mean, the heterozygote is and the combination of the two is what you think it is. And then I would think there might be the seed storage. I don't know. It could get because there's no seed. That's going to be a bit more complicated. But I guess on the upside, well, and I'm not sure where the return, because all these things need to be funded somehow, and it's a lot easier if the people selling the hybrids are pushing a little money back into the breeding team, okay, in some form. If you develop this whatever cassava clone and everybody likes it, I don't know, or you're not selling it anymore. I don't know where the funding comes in that process.
Yeah. No, I think that's an important point. Like I said, I think many of the crops that are excited about hybrid breeding is because we think it from the genetics perspective. But I think you are providing some good different perspective on how to approach hybrid breeding, thinking on the market situation and some other important things. Please, if you have a question or comment, raise your hand or just unmute. I know that this has been a short presentation just to highlight the importance of specific points in hybrid breeding. In case you actually are working with hybrid breeding in your crop or are trying to implement it and you are interested in getting the support from Randy, we will be happy to engage with you in a closer interaction to ensure that some of these aspects are sorted out in your program. I think also, some of the members from Module 2 that you're working with, they will just ask you if you want to engage in a one-to-one interaction to help you with some of the aspects like the costing and the heterotic pools, etc. All these things that Randy was mentioning. I actually allocated more time than the hour, but if there's no questions or comments, and I mean, I guess we don't have to extend it, but please, if you have a question, just jump in. This meeting still has some time.
I'm not trying to address all the comments at the moment or in the chat, but I'll be able to see those later, right? To maybe get back to those people.
Yeah, exactly. We can do that.
Okay.
Yep. Okay. Peter, do you want to maybe just say your comment, or otherwise, like Randy said, he can just address it later through an email. But Peter, we have some time yet.
Yeah, I found the presentation to be very useful because it's quite practical in terms of what is needed to motivate a successful hybrid program. So it would be, and a lot of the concepts related to producing hybrids, especially the genetic basis for it, is still relevant to cross-pollinated crops like cassava, but that are also clonally propagated. So it seems like it's a good springboard for more discussion.
Yep. Yeah, exactly. Thanks, Peter. Well, we will continue these discussions on hybrid breeding with the specific programs where Randy will engage. And if there is any additional things, please send your comments or questions and we'll be happy to address them. Okay, then thanks everyone. Thanks for joining. I can see that some people already have other meetings, so take care, stay safe, and yeah, have a good day. Cheers.
Thank you. Thank you.
Take care, everyone.
Thank you.
Gracias.
Thank you.
Thanks, great
Take care,
discussion.
Elizabeth. Yeah, thanks, Jan. Stay safe. Bye-bye.
Eduardo.
Thanks, Babucar.